Hi all, welcome back to my channel. I am Mohini Yadav, and in these video series I'll be talking about matrices and determinants. So there will be different parts on this video series, and in this part 1 I'll be talking about what are matrices and what are the different types of matrices. So first is, what is matrix? So matrix is a collection of elements which is arranged in rows and columns. So when you look at the matrix below, the matrix show the sales of essentials in kgs as per the quarter wise. So there is rice, wheat, sugar, and quarter 1, 2, 3, 4. So by this representation, we can ascertain, okay, so in quarter 1, 25 kilograms of rice have been sold. In quarter 2, 20 kilograms are sold. In third quarter, 3 kilograms, and in fourth quarter, 2 kilograms. Similarly, for wheat, we can read that 5 kilograms of wheats are sold for quarter 1, 10 kilograms for quarter 2, 15 kilograms for quarter 3, and so on. So similarly, we can also ascertain about the quantity sold for sugar per quarter wise. So by looking at this, if I want to know how much rice was sold in quarter 4, we can simply look in the row of rice for the column quarter 4. So answer is 2. So basically, matrix is just the representation of elements which are arranged in rows and columns. Okay, so if I say by this matrix, this is row 1, this is 2, this is third row. Similarly, if I talk about this, so this is column 1, this is column 2, this is column 3, and this is 4. So every time for the matrix representation, you have to just see that all your elements should be arranged in rows and columns. Okay. So next, if you look about the symbolic expressions or numbers arranged in the matrix, you can follow this diagram where the elements A11 represents 1 means first row, other one, the next one, means the first column. Similarly, for this element, 1 represents first row and 2 represents the second column. So every element is represented in the form of Mn. Okay, in the form of Mn, where M represents the row number and N represents the column number. Okay, so this is the element you can refer. So this is basically how you can represent. So if I have to find that what is the element in row second, column second, so this will be the element, that is row second and column second. So this is how you have to enter the data. If we talk about the order of the matrix, or I would say the size of the matrix, so it is denoted by M into N. So this is the way we represent our elements. So for example, this is the matrix for essential sales, which is represented by this A, and this is the symbol which is used for matrix. So this is the data we have for the essential sales. So in this example, what would be the size of the matrix? So there are 3 rows, right? So 3 are the rows, and how many columns? 1, 2, 3, and 4. So there are 4 columns. So this is how you have to write M into N, and if we have to calculate the size, so 3 into 4, 12. So the size of the matrix is 12. Similarly, if I have to find what is the element A, 3, 4, so this means row third, so this is 1 row, second row, third row. So in the third row, so this is the third row, fourth column. So 1, 2, 3, 4. So this is the fourth column, and the intersection of this is 27. So 27 is the number which is the A34th element. Simple. Next, these are the special type of matrices. So just note down all the types of matrices, then we'll discuss them in detail. So first is vector. First we'll understand about the vector. So vector is a matrix that has only either one row or one column. So whenever the matrix has just one row or one column, it becomes a vector. So for row vector, there will be only one row, that is the elements will be b1, b2 and bn, and for the column vector, there will be only one column. So these are the vector, and we can also say them row matrix and column matrix. Okay, so these are the examples. So this is just one row. So there is one row and how many columns? Right, there are 5 columns. Similarly for this, there are one column, but how many rows? Yes, there are 3 rows into one column. So this is how we have to write. So next is square matrix. In the square matrix, the number of rows are always equal to the number of columns. So in this, there are 3 rows and 3 columns. So this becomes the square matrix. So these could be 2 by 2 matrix or 4 by 4, 6 by 6. So whenever the number of rows are equal to number of columns, these becomes the square matrix, and the diagonal, these are the diagonal elements of the square matrix. Okay, so these are the diagonal elements. Simple and diagonal elements 25, 10 and 7. Next is upper triangular matrix. So upper triangular matrix says all the elements below the main diagonal. So triangular matrix are always in the square matrix. So first part, you always have to remember that triangular matrix is always the square matrix. So in this case, it is 3 by 3. That is, number of rows are 3 and number of columns are also 3. Right? So in this, below the main element, all the diagonal elements, all the elements are 0. So this is upper triangular. Or I would say, whenever the number of rows, when the number of row is greater than number of column, it is 0. So for example, in this, it is second row and first column, so it is greater, that is why it is 0. Similarly, third row is greater than first column, so there it is 0. Similarly, for this element, where the third row is greater than second column, it is 0. So this is your upper triangular matrix. Similarly, for lower triangular matrix, all the elements above the diagonal elements are 0, and this gets reversed. That is, whenever the number of column is greater than the number of row, then all the elements are 0. So this is lower triangular matrix. Next is diagonal matrix, which means all the non-diagonal elements are 0, and similarly to the triangular matrix, this is also square matrix. That is, in this example, it is 3 by 3 matrix. So in this case, all the non-diagonal elements are 0. Okay. So next is identity matrix. In the identity matrix, all the non-diagonal elements are 0 and all the diagonal elements are 1. So this you have to remember. In identity, all the diagonal elements should be 1. So this is the example of 4 by 4 matrix, and in the case of 3 by 3, also 2 by 2, also the diagonal element should be 4. So this is 4. Next is scalar matrix. So scalar matrix is similar to the identity matrix, only the difference is the diagonal element should be equal. So it could be 3, it could be 1, it could be 5, it could be 4, it could be anything. So diagonal elements are 0 and all the non-diagonal diagonal elements should be equal, and all the non-diagonal elements should be 0. Next is zero matrix. So in the zero matrix, all the elements are 0. Simple. Next, we talk about the equality of matrix. So we can equate two matrices only when the size of the two matrices are equal. When we talk about the size, it means the order. So in this case, it is 2 by 2 order, right? Both the matrices are 2 by 2. So in this case, we can equate these two matrices. So if the matrices are equal, it means all the elements are equal. So A11 will be equal to B11, A12 will be equal to B12. this A 21 will be equal to B21 and 822 will be equal to B22. So in this case B11 will be 2 and B22 will be 7. So this is the fundamental meaning of the equality of matrix, that the order is same and all the corresponding entries are also equal. So next is algebra of matrix, and this we will cover in our next part video. So in case of any doubts, please reach out to me on my YouTube channel, or you can also write in the classroom app, and please share my video so that the other students can also take the benefit of it. Thank you so much for watching this video. Bye bye.